is an Einstein ring, and how is it formed? Before we dive into the details of the massive and compact quiescent galaxy, let's first understand what an Einstein ring is and how it is formed. An Einstein ring is a special case of gravitational lensing, which is a phenomenon predicted by Einstein's general theory of relativity. According to this theory, gravity is not just a force, but a consequence of the curvature of space and time caused by the presence of mass. This means that any object with mass can bend the space and time around it, and thus affect the path of light that passes near it. Now imagine that there are two galaxies aligned along our line of sight, one closer to us and one farther away. The closer galaxy acts as a lens, bending the light from the farther galaxy. Depending on the mass, distance, and alignment of the two galaxies, the light from the farther galaxy can be distorted, magnified, or split into multiple images in some rare cases when the two galaxies are perfectly aligned. The light from the farther galaxy can form a ring around the closer galaxy. It is called an Einstein ring, and it is one of the most beautiful and fascinating phenomena in the universe. However, the observed Einstein ring in this case, that surrounds the massive and compact quiescent galaxy, is one of the most complete and symmetric ever observed. It has a diameter of about 4 arcseconds, which corresponds to about 20,000 light years at the distance of the lens galaxy. It is also very bright with a total magnification of about 40 times. This means that without the gravitational lensing effect, we would not be able to see the quiescent galaxy at all, as it would be too faint and too small for the James Webb or any other telescope to detect. You must be thinking, how did James Webb find the Einstein ring? And what was the project that led to the biggest discovery in the universe? Let's find out in this video. To begin with, what is the Cosmos Webb Survey and how does it use the JWST? The Cosmos Webb Survey is a project that aims to study up to 1 million galaxies using the James Webb Space Telescope. And with its 4 scientific instruments, they can observe the infrared light from the universe with unprecedented resolution and sensitivity. One of these instruments is the near-infrared camera, which is the main camera that can take images of the sky in 9 different wavelength bands ranging from 0.6 to 5 microns. It can also perform coronagraphy, which is a technique that blocks the light from bright sources, such as stars, to reveal fainter objects, such as planets around them. The Cosmos Webb Survey uses the NetCam to observe a large patch of the sky about 2 square degrees in size, which is equivalent to about 10 times the area of the full moon. This patch of the sky is located in the constellation of Sextans, and it is part of the cosmos field, which is one of the most extensively studied regions of the sky. With data from many other telescopes such as Hubble, Spitzer, Herschel, and ELMA, the survey is one of the first to use the James Webb, and it has already produced some remarkable results such as the discovery of the massive and compact quiescent galaxy. What if I told you that there is a galaxy out there that is so old and has stopped forming stars that it is like a fossil from the early universe? A galaxy that is so massive and compact that it is like a giant ball of fire packed into a tiny space. Thanks to the James Webb Space Telescope, we have one of those unique discoveries, a massive and compact quiescent galaxy, which is a type of galaxy that stopped forming stars and is a possible ancestor of giant elliptical galaxies. This galaxy is surrounded by a complete Einstein ring, which is a rare and spectacular phenomenon of gravitational lensing, where the light from a distant galaxy is bent and magnified by the gravity of a closer galaxy. But this galaxy itself is not only stunning to look at, but also has profound implications for our understanding of galaxy evolution and cosmology. It raises many questions such as how did this galaxy form and quench its star formation so quickly and efficiently? What are the physical mechanisms that regulate star formation and the feedback processes in these galaxies? And how common and representative are these galaxies in the early universe? In this video, we will explore the details of this discovery and how it relates to other similar observations made by James Webb. We will also explain how it was discovered with unprecedented resolution and sensitivity. So if you are curious to know more about this cosmic wonder, stay tuned and watch this video until the end. Now the question is, what are the characteristics of this galaxy? And how did Webb measure them? Let's tell you about it. What are the characteristics of the massive and compact quiescent galaxy? And how did the JWST measure them? The massive and compact quiescent galaxy is a type of galaxy that stopped forming stars and is a possible ancestor of giant elliptical galaxies. Giant elliptical galaxies are the largest and most massive galaxies in the universe, and they are usually found in the centers of galaxy clusters. They have a smooth and spherical shape, and they are composed of old and red stars. They are also very rare in the early universe, as most galaxies at that time were still forming stars and had irregular shapes. However, the quiescent galaxy that Webb discovered is one of the most extreme examples of this type of galaxy. It has a mass of about 300 billion times the mass of the Sun, which is comparable to the mass of the Milky Way. However, it has a size of only about 1.5 kiloparsecs, which is about 5,000 light years, which is about 20 times smaller than the size of the Milky Way. This means that this galaxy is very dense, with a stellar mass density of about 1,000 times higher than the average density of the universe. What is so strange about this galaxy is that it has a very old age, as it stopped forming stars when the universe was only about 1.5 billion years old, which is about 10% of its current age. This means that this galaxy formed most of its stars in a very short and intense burst of star formation, and then quenched its star formation activity for unknown reasons. This galaxy is also very isolated, as it does not have any nearby companions or signs of interactions with other galaxies. But how do we know all this? In other words, how did James Webb measure these properties of the quiescent galaxy? Well, the answer is by using its high resolution and sensitivity to observe the infrared light from the galaxy. This is the light that has a longer wavelength than the visible light, and it can penetrate through dust and gas that can obscure the visible light. It can also tell us about the temperature, age, and chemical composition of the stars and galaxies. By using the NIRCom, Webb was able to resolve the Einstein ring into multiple images of the quiescent galaxy and measure the brightness and color of each image in different wavelength bands. By combining these measurements with the magnification factor of gravitational lensing, it was possible to estimate the mass, size, age, and star formation history of the quiescent galaxy. James Webb was also able to detect some spectral features such as the hydrogen and oxygen emission lines that can reveal the physical conditions and the metallicity of the galaxy. To date, this is the only telescope that could make these measurements, as the quiescent galaxy was too faint and too small for any other telescope to detect. By finding this galaxy, we now have a new window into the early universe, which has challenged our understanding of galaxy evolution and cosmology. This discovery is not only stunning to look at, but also has profound implications for our understanding of galaxy evolution and cosmology. It shows us how diverse and extreme the galaxies in the early universe were and how they evolved into the galaxies we see today. It also raises many questions, such as how did this galaxy form and quench its star formation so quickly and efficiently? What are the physical mechanisms that regulate star formation and the feedback processes in these galaxies? And how common and representative are these galaxies in the early universe? These are some of the questions that Webb will try to answer in the future as it continues to explore the distant and ancient universe with its unparalleled resolution and sensitivity. What are your thoughts about this? Tell us in the comments. To stay updated, please subscribe to the channel and turn on the bell notification. Don't forget to like and share the video. See you soon with such informative videos. Till then, thank you for watching this video until the end.